Coming up, the Electron rocket is ready for test flights.
Mars minerals.
I'm going to talk about the NASA Centennial Challenge's 3D printed habitat contest.
And I'm probably going to screw this open. All of that and more on this last episode of 2016.
Oh, we're using that.
Hey, welcome. You've reached tomorrow. Surprise. I'm Carrie Ann, and this is the last episode of 2016, so we're all a little punchy. It's kind of like doing your job on a Friday. And this is also 9.41, which means it's the last episode, not just of 2016, but of this particular season, which is really exciting because then we get to jump into Orbit 10 in 2017. In any case, like I said, I'm Carrie Ann. I will be joined by Jared and Mike very shortly, and later on, Ben will be doing the interview. But first, I want to make sure that we give a huge shout out and thank you to our Patreon Premier members. These are the people who have given us $10 or more for this particular segment of this particular episode. Whew, I can actually spit it out sometimes. And these people have loved and supported us for a very, very long time. So thank you for that and so much more and everything you do. These people, of course, get access to our Slack channel, which I learn something from just about every single day. It's a very weird, wild, scary, strange place. In any case, if you are interested in getting your name in the show and, getting your access to the Slack channel, hit up patreon.com/TMRO. Tomorrow. Now I have a Jared and I have a Mike. And we have some launches, I think. So, Mike?
Yeah, so the first launch I wanted to talk about actually happened last Saturday while we were doing the live show. And this was a Chinese launch. This was a Chinese Long March 3B rocket, which launched a new weather satellite for China. And let's check out the footage. This launch took place on Saturday, December 10th at 1611 Coordinated Universal Time from the Xichang Satellite Launch Center. And the payload was the Fengyun 4A geostationary weather satellite. It's the first in the fourth generation of China's weather observation satellites. And with this, they have a couple new functionalities. They have a lightning detecting camera, and they also have some instruments on board to help tell the difference between clouds, fog, and volcanic ash. So that's very cool, and congratulations to the Chinese Space Agency for that successful launch.
The big joke, of course, is that we never get any footage from China because they launch something and may or may not tell us about it and or may not put out some footage. Sometimes people are like, that was it? That's all we get? Well, yeah, I mean, we're just happy to get some of that sometimes.
Yes.
Yeah.
But there was another launch that we have a little bit more footage of. Mike, tell me about that one.
Yes, absolutely. This was a very rare launch, and I was very happy for this and excited for this all year. What I'm talking about is Orbital ATK's Pegasus XL launch, which happened on Thursday. And with this, it launched from the bottom of a modified L-1011 aircraft on Thursday, December 15th at 1337 Coordinated Universal Time when it was dropped there, as you see on screen. And the payload for this was 8 Cygnus satellites. And no, that's not the Cygnus cargo resupply craft. What the Cygnus is an acronym which stands for the Cyclone Global Navigation Satellite System, which will collect wind data around the tropics that will help scientists better understand how cyclones form, grow, and dissipate. And what you're seeing on screen is the 3 different solid rocket stages that propelled these 8 satellites into orbit. Unfortunately, there's no footage of the payload deployment, but we do get this animation of that successful deployment. So congratulations to Orbital ATK for this launch. I'm always happy to see a Pegasus launch, and congratulations to NASA as well for the support from this going out of Cape Canaveral. So just an awesome launch. It did get delayed a couple of times, but I'm very glad that they were able to solve all their problems and launch that off successfully.
They solved all of their problems.
I love air launches.
They're interesting.
There's
They're
something elegant
scary,
about
though.
them.
Really? Because they just remind me of like World War II footage of bombs, and they freak me out.
to orbit.
Yeah, but
They're
I
like
don't know,
missiles to orbit.
Yes, they scare me. There's something about the propaganda that kind of got into my head, and so I saw that, and my initial reaction was like, "Wait, what did we just do?" Oh no, it's okay. It's just small satellites. We're okay.
Yeah.
Flip me out, man.
Just studying cyclones. It's no big deal.
I mean, that's really cool, though. That's really cool. And then, you get things like polar vortexes. Hi, Minnesota, how you doing? Okay, so I have to share this with you guys. We have show notes, and, we have these notes because Mike and Jared and I and Ben and everybody, we don't memorize every single thing that we talk about for these different news stories or the launches or what have you. So we have little things in here, and then sometimes we have like cute little like, hey, remember to smile, or don't forget to say patreon.com/TMRO because I always do. Okay, you're going to go to that camera and it's going to look like a blank screen, but that's totally fine.
No, keep going.
All right, I'm just going to keep going. But here, there's big, bold red letters that say, remember conversational, that I read as, remember, I almost said constitutional. What's the word? Controversial. And I was like, controversial? How is this controversial? And I was freaking out for a second, but that's not what it is. It says conversational, which is what we try to do here.
Yep.
Like to not just converse between us, we like to converse with you guys. So
as well.
It was funny because I looked down and I was like, what is it? Oh no, it's fine. So totally not controversial, but totally something we can converse about.
Yes.
How's that for a segue?
I think we can have a conversation about this. Yeah.
Mike, tell me about Rocket Lab, because we haven't heard from them in a while, and they're doing some pretty cool things.
Yeah, they apparently have just finished their qualification testing of the first stage booster of their Electron rocket. And they published a video of that first stage test. This was just a static fire test. And let's go ahead and roll this footage here. I'm super excited about what Rocket Labs is doing. So with this, you probably will notice right off the bat that they have 9 engines. They're called Rutherford engines, and they're arranged in the same octaweb pattern as on the Falcon 9 SpaceX rocket. And with this, they have accepted the first stage data that they've gotten from this test, but right now they're currently waiting for international launch licensing, both from the United States and New Zealand, before they kick off their full vehicle test flights. Now, Electron will be a 2-stage rocket with a price tag of around $4.9 million for 150 kilogram payloads to a 500-kilometer orbit. And with this, as I said, it uses 9 Rutherford engines on the first stage, and then on the second stage, it will have a single vacuum-optimized Rutherford engine that will power the second stage to get the payload all the way into orbit. So I'm very happy about this. I'm sure Minnie Stoge is as well, that something is happening so close to her. And once they are able to complete their test flight program, then they can start some of the exciting launches that they already have on their books. Probably the one that I'm most excited for is their contract to launch one of the Google Lunar X Prize teams. And hopefully they're able to qualify the rocket before the end of next year so that they can launch that flight. So in any case, I'm very happy about this. And Rocket Labs is making a lot of progress. And by the way, I should mention that all of their hardware is built in-house as well. So another cool thing that following the SpaceX model that I'm really happy about.
Totally. A couple questions really quickly in the chat room is Vogon, V-O-G-O-N, in the chat room is saying, well, who are these guys? Rocket Lab is out of New Zealand, but they do have an office here in LA, which then kind of speaks to Green Gym 2, if I remember correctly. Why does the U.S. need to give them a launch license? Are they launching from U.S. territory? I don't think they are. Are they?
So no, they're not going to be launching from U.S. territory, although they have expressed interest in using some of the spaceports here in America. Mm-hmm. They are going to be launching from New Zealand to start off, but they have licensed themselves as an American company so that they can compete in the commercial satellite market and be able to take on American payloads. Now, what that means as far as ITAR, I don't know if they have to give all of their data and all of their intellectual property to whatever authorities they need to go through in order to get these launch licensing. I'm assuming they have to share at least a large majority of that, but I don't know. And with that, because that's why they're doing this, from getting the launch licenses from both the United States and New Zealand. Initially, they're just going to be launching from New Zealand unless they get allowance to and do all the conversion work to do launches from Cape Canaveral, and I believe they were also looking at a site in Texas as well. But the main thing is so that they can, be able to get American customers and international customers as well for their payloads that they would be launching. So that's why they're doing it that way.
Gotcha. Yeah, and somebody in the chat room, Piponwa, says they used to be called Rocket Lab USA, but even that they're based in New Zealand. That's right. Yes. Everyone. Okay. Cool.
Yes.
For a second, I thought actually they were called Rocket Labs as opposed to Rocket Lab, but maybe that's just me foreseeing the future.
I've made that same mistake. In fact, maybe the chat room knows, but I think at one point they were called Rocket Labs, then changed it to just Rocket Lab, or maybe I'm thinking of a different company. I'm not sure. Totally not sure. So this is another one that kind of caught me off guard. It says Alma finds evidence for forming pair of planets. There's a woman that I work with whose name is Alma, and so I was like, really?
Yeah.
This woman just found like planets, like twin planets? That's so cool.
She did. Surprise. So
I'm gonna have to give
Twinsies.
that woman a raise.
So what do you know?
All right. So first of all, tell me what Alma is, and tell me about these adorable twins.
Okay, so ALMA is the Atacama Large Millimeter Submillimeter Array, and it is a array of telescopes down in the southern hemisphere that looks in the microwave regions, and it is unbelievable. It is incredible in the accuracy that you can get out of it. And it brings us images like this, where we're literally looking at the material of dust and gas that's forming around a star. And we call that a protoplanetary disk, because that is the beginnings of a solar system. So that's a star that's maybe a couple million years old, and you've got some of the material there. And you look at it in the great context of the area that it's in, and it really shows you just how good ALMA is at actually zeroing in on these protoplanetary disks and looking at them and actually seeing them.
So you say this is a fresh-ish star?
Yes, this is a baby star.
And how, compared to our star that we call the king of the planets, the sun?
Yes, Carrie.
How big is this star in comparison to our star?
Well, this star that we're looking at,
you know what I mean? Like, I don't even know how to compare this to.
So
because to me, this looks like a crappy tattoo on a black piece of paper.
It does.
So I need some sort of,
Well, what we're looking at here is we're looking at an area that is about 4 times the size of our own solar system.
Oh.
So that inner ring that you see there is where Neptune would be orbiting at.
Okay.
So this is a pretty big area.
Okay.
But the actual star that we're looking at is in the next image, which this star is called HD 163296.
Of course
Very
it is.
well named.
That's
sounds like a lovely place to visit, right?
That's going to be my next child's name.
Yeah, that's my bucket list place to go. HD 163296. So you'll.
Yeah, desk on this one. Yeah, Ben is saying so much better than 9.5.
Not quite as good as 163297 or 297B.
Okay. All right.
It's just the best thing ever.
Don't make me turn this show around. Okay, so all right. The two planets the size of Saturn appear to be orbiting this particular star with the really crazy name that we keep going off track about.
Yes.
Okay, and then twins.
So how do we know it?
Thank
like,
you.
how do we know that there are those planets there?
Yes.
Well, if you look at the image again, take a look at the image.
Okay.
Do you see those rings there?
Yes.
Those rings there are actually being carved out, if you will, by the planets orbiting around. So their gravity pulls the material together, and it causes these empty spaces to form.
Right.
And this is one of the first times that we've actually been able to see those empty spaces that have formed from planets forming around a star.
Got it.
We always looked on computer models and things for stuff like this, and now we're actually seeing it with an instrument that allows us to look at that at ALMA.
And Lura is asking, how far away is it? How many light years?
This is about 400 light years away from us.
Okay.
So we're seeing planets form over a distance, of 400 light years.
But 400 light years doesn't feel like that's a crazy.
Doesn't feel like it, but if you think
I know
about,
light years are crazy pants. Don't get me wrong.
Yeah.
Right. Exactly. Yeah. I'm sorry, Mike. I cut you off. Say that one more time.
Oh, I was just saying, it's in our galaxy at least.
Yeah.
Right. Because that's like.
It's like the cosmic backyard in our galaxy too. I mean, it's kind of like going out and looking at your rose bushes that are like on the other side of your backyard.
Right.
But this is like looking at a grain of pollen on your rose bushes in your backyard. This is really difficult to do. And what's cool about it is that it's looking exactly like our computer models would show us. So
That's
you
very
know,
cool.
that tells us that we have a pretty good understanding of how solar systems form. And that's very important to understanding how our own solar system
See,
forms.
thank you for saying that. That means that we have a pretty good understanding of how that goes. Because when I hear a statement like that of like, oh, we made a computer model and it's right, aren't we smart? Is the way that reads to me.
Yes.
But it's good to put in that perspective of like, so it seems like we actually do kind of understand how this works.
Yeah. Well, one of the things we want to prove with computer models is, does it work or does it not?
Right.
And then if it does work, great. We figured it out. If it doesn't work, we go to the computer model, we tweak it to figure out how it works, and then we see what we may be missing. And that's one of the beauties of using computers and computer models in order to figure things out, is that it allows us to actually tweak the variables of the universe, if you will, and then that way we're able to figure out what we need to figure out.
All right.
And of course, to me, it seems like the point of all this is to understand where we came from and where our planet and our solar system came from, how it all came to be.
That is exactly why we do it. So.
Yeah, because Marcus in the chat room is going, and how is this useful? I think, Mike, you just answered that. So
Yeah.
there you go.
If you want to know how the solar system got here, you've got to go look at how other solar systems are getting there. So.
Right. If you want to make an apple pie from scratch.
That's right.
Ben is mad at me that I made that reference. Watch Carl Sagan. It'll put you to sleep. So, things that will not
okay.
put, hey, really interesting. Really interesting. Mike, that's why I'm the
That
host.
won't put us to sleep.
Yes. What is something very interesting that will hopefully not put us to sleep?
Now, the reason why this won't put you to sleep is because it might raise your blood pressure a little bit. It did for me. What this is that SpaceX announced that they have pushed back the first crewed flight of their Crew Dragon capsule into 2018. Now, this follows a couple months after the announcement of Boeing that they had also pushed their flights back into 2018. But one thing that I am happy about is that the uncrewed test flight of the Crew Dragon is still scheduled for November of 2017. So that's still less than a year away, as long as SpaceX is able to return to flight and not have any more accidents with the Falcon 9 rocket. But with this, Boeing, their new test, they have their uncrewed test flight for June of 2018 and their first crewed flight for August of 2018. Whereas SpaceX's first crewed demo flight is scheduled for May of 2018. Now, SpaceX is also working with NASA to resolve an issue about how they fuel the rockets. The plan so far has been that they would have the astronauts get on board the Crew Dragon, seal the hatch, and then fuel up the Falcon 9 rocket. And there have been some people who have, expressed concerns over that. And SpaceX has said that they are confident that the launch abort system on the Crew Dragon capsule would be enough to save astronauts if they had any sort of anomalies, like on September 1st when the Falcon 9 exploded during fueling operations. But despite that, they are working through that, and we'll see if they are required to do it the way that other human crewed flights have been done around the world for the past 50 years, where you fuel up the rocket first. First you have to, have all crews get away from the rocket when it's fueled up, and then once it's fueled, have just a few select crew members come to, make sure that everything's okay, load up the astronauts, seal the hatch, and get the heck out of there and allow the rocket to take off on its scheduled time. But the other big important thing with this, whether or not we're going to see a change of whether SpaceX will be able to fuel the rocket as they've already planned and just rely on the launch abort system if they have any problems, or if they'll have to fuel the rocket first before astronauts will be able to get on board. But the other big thing about this is that neither SpaceX or Boeing can really allow any more delays, because NASA only has Soyuz flights scheduled through the end of 2018, and they have until the end of this year, just a couple more days, to try to negotiate and deal with Russia in order to schedule more Soyuz flights through 2019 that NASA would be paying for. After the commercial crew vehicles come online, then both NASA and Roscosmos would have each other's cosmonauts and astronauts respectively, one each, fly on each other's vehicles for free, so that there would always be, one American and one Russian cosmonaut or astronaut on board the space station at any given time. So there can't really be any more delays, and if there are, it just may well cripple the human spaceflight program for a while. So I'm very much hoping that these are the last delays and that schedules hold and that we're able to make a lot of progress next year and get the commercial crew program flying.
To be fair, it's a little bit of first world problems, right? Like, oh man, I don't know if there's going to be some delays. Like, gosh, we just are not going to have our people in space right now. Which, I mean, like, it isn't, but that's how that sounds. Like, I'd prefer to have our people in space right now. Oh, darn. But not to make that sound like that's a small thing. But I hope there is one day where that is a really small thing. Like, it's just as aggravating as your plane flight getting canceled or delayed, trying to go back home for the holidays or something like that. Like, oh, gosh, now I have to wait till the storm passes and then I can go into space. Would be really amazing. Any case, no, for sure. Of course, we here at Tomorrow are always looking to the future and that sort of thing, and we want
Absolutely.
everybody to succeed. So, better safe than sorry in general, but it's still moving along. At least things haven't been just sort of cut or canceled or stopping. Right?
Yeah, and SpaceX has even said that they are in the middle of constructing the actual Crew Dragon that will fly on the first uncrewed demo flight test. They're bending metal. That is being constructed right now as we speak. So Boeing hasn't made any similar announcement. They have been constructing a lot of test articles, but not necessarily the first vehicle that is going to fly into space. So I'm happy about that at least. There is progress being made, and we could take up an entire hour-long show delving into all the different milestones and progress that they have made through the Commercial Crew Program this year. And maybe that's what the subject of my next space pod will be this coming week, what all the milestones we've achieved this year. So we'll see about that.
Nice. Yeah, progress is progress, just period on that one. And okay, so Jared, speaking of tomorrow, as it were, and us looking forward to things.
Yes.
And, first world problems. Let's talk about Mars.
Yeah, well, let's talk a little bit about Mars because, of course, we still have a rover, actually several rovers, 2 rovers on Mars that are operating, but the bigger rover, Curiosity, is finding that the potential for habitats on Mars is a lot stronger than we were expecting it to be. So we already knew that there was potential habitats on Mars where life could have existed billions of years ago. But now we're starting to find a lot more evidence that says it wasn't just maybe these specific areas, that it actually might have been a lot more widespread than we were expecting it to be. And Curiosity is currently at the bottom of a mountain called Mount Sharp. And this is an image from Curiosity that was taken just a few days ago from where it is right now. You can see you've got that sort of array of rocks in front of it, and then the base of Mount Sharp just in front of it. Now, Curiosity is in the process of climbing from the floor of the crater, Gale Crater, which is where this mountain, Mount Sharp, is in the middle of. And it's climbing from the floor to as high as they can get it on the summit of Mount Sharp. Now, these findings were presented at the American Geophysical Union's annual conference that's happened this week, and it shows that the minerals found higher up on Mount Sharp are different from those below. And that's expected because Mount Sharp is made out of what's called sedimentary deposits. So basically, layers of material getting put one on top of each other. So the higher you go, the younger the material is. So this is actually sort of like looking back in time, but going sort of in reverse, where you start with the old stuff and then work your way up to the younger stuff.
We have that kind of thing going on here on Earth as well.
Yes.
Okay.
Yeah. So
that's
yeah,
not like a crazy weird phenomenon, right?
No, it's not weird. Like if you go to the Grand Canyon, all of the older rocks are at the bottom of the Grand Canyon. The younger rocks are at the top of the Grand Canyon, and the ages go from older at the bottom to younger at the top. Fairly linearly.
Gotcha.
Now, the minerals that they're finding when they drill into these rocks, they're finding hematite, which is a type of mineral that only forms in flowing liquid water here on Earth. So that's like slam dunk behind the back. Yeah, you found where water once was.
Right.
Calcium sulfate, which also forms from water. And then the interesting mineral that they found was the element boron.
And you didn't bring any of those for us today, did you?
No, I did not, unfortunately. I did not bring any samples directly
Figured
from
I should
Mars.
double check.
So very sorry that I could not bring them from Mars to here. But boron is interesting because that is a product of evaporation of water. So when water evaporates, the chemistry changes and it allows the water to develop boron in it, which is exciting because that means that the water was once there and there was an actual chemical interaction that the water did with the minerals in the rocks. And that's very important for us because one of the facets of life is that you have to have chemical interaction in order for life to develop. And we think that rocks are actually very important. Sort of a rock-water boundary layer is where life may have developed here on Earth. So to find a rock-water boundary layer of chemical interaction on another planet just indicates that that may have been where life could have potentially happened as well.
Nice.
So very exciting news that came out of the
questions,
AGU.
though.
Yes.
With all these different sediment deposits and the different materials that they found there, was this possibly done from a volcanic activity, or was this a lake bed that has dried up, or is this evidence of ancient Mars rain type weather that caused all these different sediments?
They're confident that there was a lake on the where Gale Crater was, and that you're basically looking at the layers deposited in the bottom of this lake. So that's what we're looking at, the bottom of a lake bed.
Gale Lake.
Yeah.
Very interesting.
Gale, I guess you could call it Gale Lake if you wanted to. It's actually it's a very similar process to the same things that we get with the dry lake beds out here in Southern California and in Central California out in Death Valley. It's almost exactly the same process, except it's happening on a different planet, maybe with a little bit different chemistry as well, since there's more iron involved with it. So
I have a question.
very cool stuff. Yes.
If we begin to melt some of the underground ice that's on Mars, will these lake beds begin to fill back up?
It would be, you could potentially get the lake beds to fill back up, but one of the problems is that Mars's atmosphere is very, very thin. So you have to have the water. Very, very salty or basically brine in order for it to be liquid. And then even then, it doesn't stay liquid for a very long time.
It just boil off because of low pressure.
So it literally goes from a solid to. I mean, it wouldn't even boil off. It would go from a solid to a gas. It would sublimate directly. So.
And for those of you who've never seen this show before, that would be another one of our hosts, Ben, just ever so slightly off camera, asking questions while mic'd up.
I'm allowed.
That's true.
Sure, we'll say that.
Yes.
That's about it for our news segment. And when we're going to break for a little bit, thanks for that. And when we come back, it will just be Ben actually doing an interview that ties in nicely with this. He will be interviewing Eric Reiners and Dr. Pelin Gultekin-Bicer.
You'll do that better than I will.
Probably. At least you've heard it once now. So when you do it,
I better not screw up.
You better not screw up. They're coming at us for the NASA 3D Printed Habitat Challenge, which is a really kind of a cool thing. Talking about 3D printing habitats on Mars, possibly, which is really, really cool.
Cool stuff.
So we'll go ahead and take a break, and when we come back, that's what's going to happen. See you later.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
And welcome back to Tomorrow. My name is Benjamin Higginbotham. Now, before we get started, I did want to give a huge shout out to all of the patrons of Tomorrow who've helped make this specific segment of this episode happen. These are people who've contributed $10 or more to this specific episode. We've also got our Tomorrow producers. These are people who've contributed $5 or more to this specific episode. We are a crowdfunded show. Every single dollar helps. Head on over to patreon.com/TMRO for more information on how you can help crowdfund the shows of tomorrow. All right, we're going to be talking about the NASA Centennial Challenges, specifically the 3D habs project. And joining us today, we've got Eric Reiners and Dr. Pelin Gultekin-Bicer. Dr. Pelin, give me your last name again. I'm sorry, I screwed it up.
Gultekin-Bicer.
Oh, all right. That was close. All right, you're joining us, Dr. Pelin. You are an assistant professor in the Department of Civil Engineering and Construction at Bradley University, and Eric, you are a program manager within the Innovation and Technology Development Division of Caterpillar. Caterpillar being, like, I think of Caterpillar, the big giant machines, correct?
Well, we do make those. That's correct, but. A big part of what we do with that in our products involves technology to make that possible. So,
all right, so let's back up a little bit and talk about, you're both working on this NASA Centennial Challenge. First off, what are NASA Centennial Challenges?
So the NASA Centennial Challenge is a program within NASA that's focused on incentivized R&D. So NASA offers prizes to incentivize people to go try to solve a problem and develop the technology to solve a problem. And so it's very analogous to, and it's actually modeled, I think, after the X Prize, which maybe a lot of the viewers may be familiar with that.
And so what specific problem are you guys trying to solve here?
So this competition is really focused on how do you solve the issue of habitats, both for Mars and NASA's mission there, but also here terrestrially. And how do we grow the technology base here on Earth as well for automation in construction and improving the overall construction process.
And is that where Caterpillar comes into this particular area?
Yeah, it is. So Caterpillar's been involved in innovation for infrastructure development for the last 90 years, and we continue to be focused on that into the future. And this is an area, one of those areas that we can talk about of things that we're doing and looking forward into the future.
And Pelin, what is your involvement in the 3D Hab Challenge?
Actually, in this competition, we are the host, and we are collaborating with NASA, and with the support of Caterpillar, Bechtel, and Brick and Mortars.
And so, as the host, what are your responsibilities for this project?
We are organizing the event with our collaborators. So we set up the rules, and we are now collecting the applications. Then we will organize the competition on site and collect the submissions.
What are some of the rules for this Hab Challenge?
Actual rules, the goal, starting with the goal of rules, this is a series of competitions to advance additive construction technology for the creation of a sustainable housing solution on Mars, as well as on Earth too. So our goal is to innovate new material compositions as well as autonomous printing processes. So in this phase, which is the structural member, we have 3 levels. In the first level, we will be asking competitors to print a cylinder for us for the compression test. At the second level, we will be asking them to print a beam for the tension test. And at the last level, which is going to be on site, we will be asking them to print a dome with an autonomous technology.
And we have some images from some different phases of the competition, I believe it is. I think there was like a first, second, and third prize that was given. Dada, let's do these in reverse order. Let's do number 3 first. What are we looking at here? What was this part of the competition?
Yeah, so NASA's constructed this Centennial Challenge program into 3 phases or buckets, approaches. The first was a design competition, and that's what you're showing right now and the results of that design competition. So this was really about involving the dreamers and the artisans and the architects as to what might the habitats look like for Mars. Now the next phases get into, well, how do we really be able to execute those habitats for Mars and the technology for that and for Earth? And so the next step is the structural phase. So the focus, as Pelin was referencing, is for the teams that choose to compete to come up with the material and the structural performance of that material in the next phase that we're starting right now. And then following that will be the final phase where they will take that capability and actually build a full subscale habitat structure that would fit on, say, an 18 by 16 foot size pallet. So that'll be the size of structure that they will ultimately be able to print in the final step. And in this current step that we're starting right now and engaging on, and how the rules have been constructed, it's really constructed to drive material development that will leverage, from a sustainability standpoint, things that for NASA are going to be, they'll be taking with them as part of their packing materials. And on Earth, they're part of our traditional waste stream, and it's another way of using that in a much more sustainable way. So an example that would be that, for instance, teams that were able to come up with a material formulation that leveraged the plastics in water bottles as a binder for this material would score very well in the rules, as an example.
Which brings up an interesting question from the chat room. Jazz Throughout asks, what materials do they 3D print with? Are there restrictions on that, or can they pick anything they want, be it found here on Earth, Moon, Mars, etc.?
Yeah, so the point structure is set up to drive the teams to try to come up with material formulations that will be based upon materials that will be found on Mars and on the Moon. So, for example, the regolith, so the rock, the sand or the rocky material that's in the, it's a component of the material. Being basalt, for instance, will score very well because basalt is prevalent on Mars and on the Moon. And then likewise on the binders, things that would be traditionally they would be taking with them in their packing materials and so on that they already have, and now they can reuse it. So one of the goals for NASA is to try to minimize the amount of mass or material they have to take with them to be able to construct the infrastructure that they're going to need on the surface of Mars, for instance, because it's so expensive and prohibitive to launch all of it from Earth.
We are also discouraging the use of water as well. We are encouraging the use of indigenous materials and recyclable materials used in missions, but we are discouraging the important materials and the water in the pointing system.
That's interesting. So you get to the Moon, there is potentially tons of water on the Moon. We don't want to print with that because we want to use that as, say, water for radiation protection and for human habitation, or are we thinking that the process there is there won't be water where we go?
I think that NASA's some of their driver is if they can minimize the amount of water that they need, then they don't have to drive a lot of previous activity to be able to extract that water ahead of time to do the infrastructure, some of the infrastructure construction. Because some of the things beyond habitats that they may be looking at needing to build could even be with, for manned missions, could be landing pads. Because of the size of the landers, the amount of thrust that they'll be creating, there are some risks that the spacecraft may create craters themselves as they try to land and so on. So if they end up needing some amount of landing pad or things like that pre-placed, minimizing the water that has to be essentially mined early on, material formulations that do that could be advantageous for them.
Trebles has an interesting question, which is, let's say a competitor makes good structure. Is there a plan to get that in actual use on Earth, or is this just a challenge for, say, Mars or the Moon or space habs?
No, I think the application on Earth is very much of an interest. Looking at materials that can be part of a sustainability effort. As we referenced before, plastics from water bottles and soda bottles, for instance, are prolific in our waste stream, not just in developed countries, but also in third world countries as well. And if we can utilize those materials to build our structures that are needed going forward, I think there's great benefit terrestrially for that. And we're seeing the need, ongoing need, as we look out into the future with the projected population growth here on Earth and the shift in the standard of living in that population for significant need for housing as we look forward into the future. And so what are the ways that we're going to be able to construct that housing quickly, efficiently, cost effectively?
So is this potentially, this technology is more than just habitation on Moon and Mars. This could be potentially the way we build our houses in 100 years.
Absolutely.
Interesting question. I'm going to combine two questions from TWicked, which is, will the habitats have to be fully 3D printed, or could they be inflatable shells with like an exoshell? So do you have to 3D print it from top to bottom, or can you kind of, can you use lava tubes on the Moon to make part of your habitation, or use existing structure somehow?
In this process, we want it to be autonomous. This is the first rule. So, and the 3D process is the method, since we don't want astronauts to build a like a construction project over there. So that's why we are encouraging to use the 3D printers.
Is there a budget limit? Treble's asked, is there a budget limit? Is this just about technology, or are there economics in this as well?
Well, the budget is really going to be on the teams, the teams that decide to enter and compete. And so how the competition works is that there are rules that are developed for these phases. And this next phase that's underway and registration is open. The rules are posted out at www.bradley.edu/challenge, and they can find those rules. And along with that is the structure of how the prize money will be implemented. And that's really the NASA and the sponsor side. NASA will be providing the prize money. The sponsors, Caterpillar and Bechtel Corporation, and Brick and Mortar Ventures, working with Caterpillar, will support Bradley then in the execution of the competition. And so this next phase that we're starting right now will have some aspects of it that the teams will do locally in their own team center, wherever that may be, and they do some testing that they have to provide those results back. And then that'll culminate in a on-site head-to-head competition at Caterpillar's Edwards training facility just outside of Peoria, Illinois, where both Pelin and I are located.
And the total amount of awards are $1.1 million. And these awards will be distributed in different levels. So for example, a team can join at level 1 and can be at one of the first teams, and then they can earn some money to invest in their second level. Then they can use the second level awards for the third level too.
Need your mic, Ben.
In the end, they're ultimately owning this technology that they've created for these habitations. So that's kind of their incentive as well. Not only do they get these reward levels, but now they're kind of the kings of this new technology and can actually go out and start doing these things, correct? Or do you own the technology at this point?
No, the teams own the technology. They have the rights to the intellectual property that they're creating. And then, of course, at the end of this, then there's multiple things that are opportunities that they could have with Caterpillar and with some of the other sponsors to look at ways of continuing to move forward with the technology development.
You mentioned demoing this here on Earth in subscale models. Are there any plans to demo this on the Moon or on Mars as well? Is that like level 4? Like, let's put this on the Space Launch System and sling it over to the Moon and let's build a hab?
Well, I think ultimately that's what NASA wants to see happen from this technology development. I think there'll be a fair amount more work to do on the technology past what we're going to do in the competition before it's flight ready, if you will, from a NASA mission perspective. But that's one of the benefits of working early in these kinds of phases with NASA, with private industry, is the ability to work on technologies that have multiple use capabilities, so that ultimately can meet NASA's mission objectives, but also have value here on Earth terrestrially.
And what about something outside of kind of this scope? So we're talking about habs, but habs don't have to be on the surface of anything. So Zweeby, I think is how you pronounce that username, is asking if you can 3D print an airtight habitat in place without an atmosphere, can you adapt that technology and print maybe a space station or a floating habitation? Does it really matter, like, how you get to the habitation? Do you care if it's on a surface, or is it any sort of habitation, be it in space or on a body?
Well, I think for this competition, the focus is a habitat that would be on a surface. But certainly, I think as we get to understand the technology better through this process, I think NASA could certainly be looking at, is it viable to do things with it in space as well.
I think it's kind of cool that Caterpillar is one of the sponsors of this, because it's an interesting tie-in to kind of the future of construction. How did you guys decide that this is something that you wanted to do?
Well, we were made aware of it in NASA as part of some of our other ongoing activities with them. And as we saw what they were laying out from this competition standpoint and the longer term potential of the technology and how it can impact things here terrestrially, it fits very well with who Caterpillar is and how we support, drive innovation, and deliver capability to our customers worldwide for them to enable progress in infrastructure around the world.
And where can people go for more information on the Centennial Challenges and specifically the 3D Hab Challenge?
You can find the rules on the website, which is www.bradley.edu/challenge. You can find rules, you can find frequent asked questions that we will be updating it monthly based on the questions that they will submit to us, and related drawings that needed to be printed on the same website.
Dr. Pelin and Eric, I want to thank you so much for taking time out of your Saturday and joining us, talking about the 3D Challenge. This is going to be really cool. This is kind of the future of habitation, right? We're not going to bring huge, giant habs to Mars. We're not going to bring giant habs to the moon. If we're going to colonize these areas, we're going to have to figure out how to do this in place in those locations. So this is a critical technology for colonization of the solar system. And then that can be reused here on Earth. So I think it's actually a very, very important challenge, and it's going to be very, very cool. And I appreciate you guys taking time to talk to us about that today.
Appreciate you having us.
All right, we're going to take a quick break, and when we come back, comments from our last week's show. Stay tuned. We'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation. This girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking. She's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking. She's fire walking to be free.
Hey!
They're being mean to me.
Welcome back to Let's Be Mean to Ben. Now, before we continue being mean to Ben, let's go look at some of our Patreon patrons.
All right,
we have
yes,
here.
yes.
With our Tomorrow
Please,
Premier
let's do
members.
that. Yes.
These folks gave us $10 or more per episode. But wait, we've also got our Tomorrow producers.
Look at how tiny the font's got.
These
It
folks,
had
I
to,
know.
otherwise it
I'm
doesn't fit
enjoying
on
the
this.
fact that it's
so
gotten
many
so
people.
small.
Yeah.
I told you need to circle your name, otherwise you'll never find it.
With the Sharpie, like
With
has
the
been noted
Sharpie.
before. And these are our Tomorrow producers. These folks have given us $5 or more per episode. They get free worldwide swag store shipping. But wait, there's also our Tomorrow Plus members. Not only do they get their name in the show, they get early After Dark access. And these folks have given us $2.50 or more per episode. But wait, there's also our Tomorrow Patrons. These folks have given us up to $2.49. They get their name in the show and access to Google Hangouts when we do them, which I think we need to do one sooner rather than later.
Definitely
so, especially to show off the set that we're looking at, which this set and everything coming up for Orbit
cool.
10 in just a couple weeks is thanks to all of you, our Patreon patrons. If you would like to be a patron of the show and help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO.
Yeah, Dada's turned into like a freaking AI with that crap. Say it! Just say it or I won't get off of this slate.
He won't leave the slate until you say tomorrow.com/ or patreon.com/TMRO.
That's fine. I was
And
not
I
waiting
watch him
for-
through the glass because I can see like straight on the way. I look this way. I'm watching him look at the screen, and you can see the smile start creeping up his face and going, "You better say it, because I'm not leaving this screen. You better say it."
Also, you're welcome, people who have given us only 5 cents for this show. For
can't
getting
do-
your name on the show for way longer than just about anybody else, other than the Patreon Premier members who get their name in the show way more multiple times.
I learned you can't do that anymore.
What? Can't do what? Do 5 cents?
The minimum bid now.
Yeah.
Bid?
Bid?
Apparently it's an auction. The minimum amount you can contribute apparently is $1 per
Okay.
Patreon. So anyone who contributed 1 penny is grandfathered in, but anyone new showing up, and the reason I stopped saying between 1 penny and $2.49
Right.
is you can no longer contribute 1 penny to the show. You must contribute $1 per episode, which is $4 per month.
So, first of
nominally.
all, that means thank you
Nominally.
for those of you who got in way early, even if you were only giving us a penny, because every singular penny does in fact help. And
Yes.
then 2, hey, way to get your name in the show for like way cheap. And we also just learned that Ben can be bought.
we knew that though. I
was
feel
about to
like
say,
we knew
We
that.
didn't know that yet. We know that.
Yes.
It's good to know. Not sure what that says about me.
I need to talk to Patreon and get that fixed because I want people to be able to contribute 1 penny to
Yeah,
the show.
at any level. That should just
at
be
any
a
level,
thing.
right? If you want to contribute in any way, maybe we need to find a way where if you can't afford to contribute, you can donate time instead of money.
Like render time.
Oh God, I could use that. Actually, I don't like the word donate. Anyhow, after dark conversation. Capcom, get us started with some comments.
So at some point we stopped doing the hashtag and naming the show. So I looked at this particular name of this show and said, wait, what did we talk about?
By the way, Orbit 10, we're not even doing the named bugs anymore.
Perfect, because apparently the previous show's topic was Space World, and I had to go back for a second and say,
Yay,
what
Space
were we
World.
talking about? Right. I nearly
The game.
forgot. So yes, we were talking about the game.
Yeah.
As you can tell, I am not a gamer. So
Or a lover of Carl Sagan, apparently.
I do love Carl Sagan.
That's blasphemy.
She's
you're a
not
space
necessarily
person.
wrong. If you listen to him for hours on end, he's very inspiring, but his voice does have a certain cadence that is very soothing.
It really makes you want to go to sleep.
Just a little bit. It's not that he's boring. He just has a very soothing cadence to his voice.
Yeah.
So if you wrap up in a nice warm blanket on a nice cold day, turn on Cosmos, right? Exactly.
Yeah,
right?
see,
It's
it's already making me
Yep,
sound just
Right.
thinking
it's,
about.
it's very inspiring, but also very soothing at the same time.
Let me be clear when I say that space in general, kind of boring until you put it in an interesting way, if that makes any sense. And if you
Yeah.
doubt me for any moment, go back, search on the interwebs for Space is Boring, Space Up Talk, particularly Andy Cochran, if you can remember that part of it. But Space is Boring, Space Up Talk, or T-5 Talk, and you'll see exactly what I'm talking about. He's not wrong. Okay, let's move on.
Yes.
This first comment comes from Ryan Ham.
Longtime commenter.
Yes, off of YouTube. Ryan says, I disagree that Blue Origin launched and reused the first rocket to space. That distinction belongs to X-15, 56, 66, 72, in my opinion.
It depends
Also a name that
on
trippingly comes right off the tongue.
Yeah, I know. Blah, blah, blah. I think. All right, this is another one of those how are we going to define it moments, right? So.
Oh no, not this. again.
It is. How do you define it as a rocket? That's more of a space plane. It's more of a plane than a rocket.
It's a rocket glider.
It's a rocket glider, but
All right,
it's not.
Okay, no, I can shut this one down really quickly. It was, who did it, what was the significant thing that happened in 2016? Somebody said that the Blue Origin was the first person or first company to launch and reuse a rocket in space. You can say with the qualifier of in 2016, there, we're done. Anything else?
Well done. That sure shut it down.
Yeah, there's that.
I mean, there is that, but it does come back to the. No, it's not going to shut it down. It does
I
come
know,
back to the
'cause it's Ben.
because it's me. How are we going to define a rocket? Right?
Right.
Was the space shuttle a rocket?
Is the space shuttle a rocket glider
Had
too?
rocket
Says
engines.
Region
It's
2.
a crude hypersonic rocket glider.
Space plane.
Brick.
Pippenwa says, what is Pegasus,
Go
a
ahead,
rocket
Dada.
or a plane?
Right? Yeah. Yeah. Exactly. Dada?
Brick.
Brick.
It's a brick.
It's a
Brick
space
with
brick.
wings.
space brick.
Hypersonic space brick.
Hypersonic space brick.
You're a hypersonic space brick.
But the X-15 was not a hypersonic space brick.
Right.
So is it a rocket or an
still didn't have a-
airplane
it
or
still
a
didn't-
rare plane?
It still had a really crappy glide ratio.
But it was still rocket powered though, and the same rockets that powered the X-15 were powering sounding rockets and some of the first rockets in like the Vanguard program and stuff like that.
So where's the
I don't know,
transition
like-
between
Right.
rocket and airplane?
Right,
then?
because Vogan says, can't rockets have wings? Or can rockets have wings?
It was
Sorry.
a crude rocket.
Vertical,
Well, I don't know.
Vertical
Can
launch.
rockets-
Also a space plane.
Go ahead.
Vertical launch.
vertical launch.
I think you have to make that distinction
Yeah,
because
let's
X-15
give
was
Blue Origin the credit for having the first vertical launch that landed the rocket successfully.
first private company to vertically launch.
Yeah, all right, that's fair. So I guess
you have to put all these qualifiers on it in order to be able to say.
No, I think simple qualifier here. If you launch and land horizontally, you're an airplane.
Launch and land horizontally your plane?
Yeah.
Yeah,
Okay.
right? Because that's what the X-15 did. It launched
launch or land horizontally, because to include the space shuttle, you have to have both qualifiers.
God, new shuttle.
We're moving on.
New shuttle.
Stupid
Why?
Ruining everything.
Why
in the
did you
space
do
shuttle.
this to a space shuttle? Why? Look at me when I speak to you.
Calm down, guys. Calm down. It'll be all right. It'll be all right.
Totally
Let's
not
all agree
awkward
that
at
the Blue
all.
Origin flights were awesome this year.
Yep.
Let's
So
just agree on
the
that.
Blue
Yes.
Origin flights were in fact awesome. Leave your comments. We may or may not bring them up in Orbit 10 because of the long duration between this show and the
Right.
next one. But I'll watch for them and we'll comment in text. But leave them on YouTube, Facebook, wherever. All right, moving on.
Yeah.
Capcom.
This one comes from Taiwan John. My problem with the Nat Geo Mars series is the implausibility of the various quote-unquote challenges faced by the crew, which point to a really boneheaded mission architecture.
They do.
Yep.
Yeah.
They do.
Yep.
Like
There
there
are a
are
lot of-
simple solutions to these things that they're making overly complex for the
This was
sake.
not meant for us.
I know.
I know, but you watch it and you just go, good Lord, these people are unprepared. Like, who sent these idiots? Imbeciles.
And mission control.
Yeah,
Mission
mission control's like,
center,
I don't know what to do.
It is a little
Like, what are we
disheartening, I
working
will
with?
say.
Fourth graders
Mission
here?
control's going, how can we make this a worse situation?
I know what we should do. Let's build it with Legos and then figure it out.
Oh, man. Someone's critically injured and needs to get to the hab. If we send everyone, it's going to be too heavy. All right, well, don't leave half of the people in the area that has habitation already and only send 2 people over to the new hab. That would be too smart. Send everyone and put everyone's life at risk instead.
Yes.
Come on, guys.
No man behind, man.
Jeez. But it's still fun, and a lot of it, other than I think the science is correct. It's just the troubleshooting isn't. How's that? They got the science right. They just got the troubleshooting wrong.
I want to like have a camera attached to like a TV and have someone like Elon Musk or Robert Zubrin watching it and just seeing their reactions to how the crew's working. Because I could see like Robert Zubrin being like, "Well, this isn't working like how it's supposed to actually. Like, what are they doing?"
I can just see
That's
Elon
not
going,
good.
nope. Just kind of doing his, just he wouldn't even say it, just kind of shake his head. Anyhow, next up.
Yeah.
The saving grace there is that there's only one more, so it's almost over.
It's not a bad series.
I didn't say it was bad.
And it is fun. And the previous episode we just watched was interesting and touching, and like it was a fairly emotional episode. It was well done. It's just like you said, not for us.
Yeah. I kind of have no desire to watch it.
You've not
anymore.
really?
So yeah, because it was just so like Hollywood. I was just like, I can't do this.
All right, that's fair. Yeah. Okay.
All right, next one off of YouTube from Attic Land. You've been talking a lot about all these best space moments in 2016, but what do you think we'll remember mostly, say, several decades from now?
Space Mike, what do you think? What do you think is the moment in 2016 where 20 years from now they'll look back and go, that happened in 2016?
Right off the bat, I want to say the SpaceX landing, but the first time that they did it was actually in 2015. So I think that will be the first, rocket landing, the orbital rocket landing will probably be remembered for 2015. But gosh, I don't know.
Will
That's
it
what I
though? I
wanna
kind of
go
feel
with,
like it's
but-
one of those things where you ever try to remember when one of your favorite songs came out. You were like, oh man, I was in high school. I was like a freshman. So gosh, what was that like? It was, I don't know, it was like 2015, 2016-ish. You know what I'm saying?
Yeah.
I feel like it's just going to kind of get weirdly lumped
Into this time
together.
frame, right? 2015, 2016.
Yeah, be like, I don't know, that was like the mid-20-ish. You know what I'm saying? Like, I feel, maybe that's just me, but I kind of feel like that's just it won't be this distinctive like this is exactly
That
what
was
it
in
was.
2015 on
Right.
December 21st.
Other than SpaceX huggers, which they're out there, that it'll just kind of get lumped in of like I think that was like late 2015, early 2016, right in there somewhere kind of situation.
I'm also kind of agreeing with the chat room. I think that depending on how things go in the future, that the announcement for the interplanetary transport system might be one of the big things. Like, oh yeah, remember
See,
when
but I don't think so with that either. I'm sorry, Mike. I keep trying. I'm taking all of your stuff away.
Well, we'll pause you. You can do yours.
Yeah, all right, go.
All right, so Jared, what do you think?
For
Are you
me-
gonna? I assume you're going to agree with the chat room.
For me, it's going to be the discovery of gravitational waves.
Boom! You, Cresthead, Lur said the same thing.
Just because
absolutely.
in terms of astrophysics, that's what we've been looking for a century, and it's been so much work put into that. Now we're doing it. We literally have a new way to look at the universe. It's just it's the most amazing thing to me that we were actually able to do it. And now we're going to be doing it with even more sensitive instruments. And we're going to learn so much from it.
Carrie, on your turn. Now you can do your...
I don't know, but I disagree that somebody making plans for something is going to be remembered as the thing that we're going to be talking about decades later. Like, unless it was just one of those things that's so spectacularly flops or so goes ridiculously amazingly well, I just don't think it's... I don't know.
You don't think that would be the tipping point? Like when people look back in the
No,
past
'cause I
and
don't think,
look
hey,
for that
remember
point?
that one time that one person made some kind of talk once? Like, that's never a conversation I've ever had.
No, but if
Remember that one time in 2000 that when Richard Branson said they were 2 years away?
Oh, I remember.
That's what
I remember.
saying. Yes, that doesn't feel like... I don't
But
know.
there's a difference. If SpaceX does what Elon said in that time frame, wouldn't that then be like, well, this was the beginning of how we got there?
I don't know. I don't look back on. So I'm a huge Disney person, right? And I go to they have a biannual conference here in Southern California called D23. I don't go back and go, I don't know though. And D23, they said in December of 2016 they were going to release Rogue One and it was going to be a big smash hit. And oh my goodness, it was a smash hit. Like, I don't have that thought process. I don't have that like.
Remember the movie itself, not the announcement of it.
Yes, exactly. Or if Rogue One didn't come out in 2016 and it came out like 4 freaking years later, be like, man, they've been promising Rogue One for 5 years now. I don't get it. What's the big problem here? Or if they were like, hey, you know how we said 2016 and December 2016? We actually meant next week. Woo! Like, that would be crazy pants. And then I would remember that they had this announcement. You know what I mean? Like, just because you go, hey, I'm going to do something, and then you do it, that's not memorable to me.
Kennedy's speech.
What about Kennedy's speech?
That is a pivotal...
What date was it?
I don't know.
Where did he give it at?
I know he did before he died. Guess what? I'm not even
University?
positive what year he died.
I have
That's
to side
terrible.
with Carrie Ann on this because the first example in my mind is the voice of Julie Andrews from one of Disneyland's fireworks shows saying in 1955, what year did Disneyland open?
1955.
All right, so what year did he start thinking about it?
1954.
Right, when did he
No,
make the announcement
no.
for it?
When did he start thinking about it?
All right, that's fair.
Yeah, I don't.
I actually don't know.
I'm sorry, I just...
Exactly, nobody does. They started construction in 54. They opened in 1955,
So-
and that's the date that everybody remembers.
So the pivotal moment
so
won't
if
be
you-
the announcement. The pivotal moment will be the first thing, like first opening, first landing, first launch, first tangible thing.
When they build ITS and they launch it, that will be the date that's remembered. When SpaceX lands a booster and relaunches it and uses it to loft the payload or put people throw people up to ISS, that's the date that will be remembered.
Yeah,
Not that they recovered 6 boosters ahead of that and did all this testing and blah, 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 or the date that the first one landed. The date that will be remembered is when they do it.
Okay.
Yeah, because you guys are saying, you guys keep bringing up that particular speech. Yeah, I agree. I really like the speech. It's a great speech. I can't tell you, half the time I forget where he did it. He did the speech more than once, first of all. But it's the Rice speech that everyone always remembers.
And then in a joint session of Congress.
Yeah, but I couldn't tell you. I couldn't tell you when that was.
It was reversed from that, wasn't it?
The joint session of Congress first, and then,
which
and then
actually
Rice
was a
University.
slightly different speech. Anyhow, okay.
Right, it's all of that kind of stuff.
I think that's a fair point. I think that's a fair point. We've hammered that.
Do you have anything else to add, though, Ben, as to what you think the biggest moment will be of 2016? Remember decades from now?
I actually don't think there's a big moment in 2016 that will be remembered 2 decades from now.
Not in space, anyway.
Not. Not in space.
Yes.
Yeah.
I know what that sound means.
Oh, that's a great sound. Okay, so last comment, right? Because we're moving on at this point.
Dutta, can we move on? Okay, yep.
Yeah.
That sound means I need to check with Dutta to make sure we can continue to do the show.
It
Yep.
just means the elevators finally hit the floor. The last one comes from YouTube. This is Bobbert for him. Says, wouldn't it be more appropriate to say that dark matter is merely a theoretical construct that was invented to explain the unexpected behavior of interstellar matter? Theoretical physics could have just as well said that all those galaxies were rotating so quickly because of space fairies, which actually would have been hilarious.
Oh my God, that's hilarious. Yeah, I think this is in reference to a comment you made last week talking about dark matter. And dark matter isn't a real thing. I mean, it is a theoretical construct, right?
It's not a theoretical construct. Dark matter is a real thing.
All right. So
And
it's
we
not,
know that dark
it's not
matter,
space fairies?
So let me put it to you this way. We know that dark matter is a real thing because we can see its gravitational influence on objects.
But do we know what it is?
We do not know what it is. We call it dark matter because in electromagnetic radiation, or the EM spectrum, basically light, it does not give off any electromagnetic radiation. But we know where it is, we can map it out, and we can see its influence by the gravitational force that it exerts on things.
So dumb question then. Not knowing what it is, but knowing there's something there, doesn't it still make that a theoretical construct? Because we don't actually know what it is.
We don't know what it is, but we do know that it is real.
Well, but
that's like saying
wouldn't that be a theoretical construct?
No, but UFOs aren't a theoretical construct. They quite literally are an unidentified flying object. There's an object, it is flying, but I don't know what it is.
Yeah.
That's not a theoretical construct.
Sure, but it still could be space fairies. I mean, calling it dark matter is just, we haven't actually figured out what it is.
Well, we call it dark matter because it's not giving off light. Basically.
Well, space fairies may not give off light.
Yeah, for all we know, but I haven't found any evidence that space fairies exist yet.
I really want to call it space fairies based on this comment.
Yeah.
My theory is that it's just dust that's really heavy, maybe some sort of soot or something like that, and that's the reason why we're able to detect all this gravitational pull from it. But
maybe it's the MDF dust from the studio.
I think it could be.
Could be is what's pulling the universe together.
You know how you lose a sock in a dryer every once in a while?
Yeah.
Maybe that's where all the socks are going, where the dark matter is. It's just really big clumps of socks.
All right. Was that the last one? All right, that's the last comment of the year.
That's
the year. This is our last show for 2016. We will return in 2017. I believe January 7th is our next show. Starting Orbit 10. We've got a great deal of work ahead of us to complete at least this part of the set. I'm very excited to show everyone what we've been working on for the last 6 to 8 months at this point, hasn't it been? I mean, it's been a long time. I will say one of my favorite moments and one of the tipping points for this show will be this studio in 2016 and getting this space and being able to do these amazing, incredible things. That's going to be, I think, a pretty big game changer for us. The biggest game changer for us is probably Patreon. This will be the next. Patreon enabled us to do this, and so I'm super duper excited for us being able to do it. One of the other things I want to do for you guys, and I'll mention it in the proper show, and then maybe I'll go into a little bit more detail in After Dark if I remember, which is the idea that we have the studio space so we can do more than just Tomorrow Space. We want to do Tomorrow Energy, Tomorrow Transit, Tomorrow Tech, things like that. And one of the important factors here is that I'll have to list this out in like a Patreon post or something, but Tomorrow Space is at the center of all of that. Just like space is at the center of technology and energy and transportation and everything in our real lives, it too will be with our shows. So it's basically there's a circle of things, and in the middle of that circle is Tomorrow Space. And Tomorrow Space feeds the other shows, and the other shows feed back to Tomorrow Space, but it all ties back to space in one way or another, which is why we started with space. It's all going to be related around space, but there will be, not next year, but there will be, in the grand vision of things, additional shows that we'll be able to do. And I'm really excited to be, this is the year that enabled all of that to happen, hopefully. And so I'm very, very excited for all of these things. And I'm very thankful that we have Space Mike and Jared, Carrie Ann, Dutta, Kitty, everyone who works on the show. We actually had a picture not that long ago of everyone. It does take us, it is actually amazing how many people work on the show with
Lisa and Josh.
Lisa and Josh as well. We should post that picture sometime. And maybe that'll be the thumbnail for this show. Nah. Thank you so so much, everyone. I'm super duper ultra excited to share Orbit 10 with you. If you're a patron, definitely check out patreon.com/TMRO. Log in, view the feed. You can see the building of the set and everything that's coming along. And it's been an incredible year. It's been kind of a depressing year, but it's been incredible nonetheless. It's been great in space. In space, it's been a great year. So thank you, everyone, so much for watching. We'll see you January of 2017.